This week, Paul and I interview Mike Shima, head of product security at Square. In the news, Facebook stored hundreds of millions of passwords in clear text for years. A zero-day in WordPress SMTP plugin comes under siege by hacking groups, and how human contact is slowly becoming a luxury. Stay tuned for all that and more on this episode of Application Security Weekly.
This is a Security Weekly production. Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies, protecting over 7,500 applications and 150 billion production requests per week. Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences patented technology protects any application against any attack, with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at signalsciences.com/PSW.
Welcome everyone to episode 55, our 56th episode of Application Security Weekly. For the final time, I am your host, Keith Hoodlet, and I'm happy to be joined once again by my good friend, Paul Asadorian.
Hey,
Paul.
Keith, good to be here today. How are things going?
Good. We're also joined, by the way, by CEO of Security Weekly, Matt Alderman, in studio. Good to see you as well, Matt.
Always a pleasure, always fun.
Awesome. One quick announcement before we jump into our interview today. Join us April 1st to the 3rd, which, by the way, is next week. So if you don't have your tickets, it's Disney's Contemporary Resort for InfoSec World 2019, where you can connect and network with like-minded individuals in search of actionable information. Visit infosecworld.misty.com and use the registration code Oscar Sierra 19er-SecWeek for 15% off the main conference or world pass. If you're interested in booking an interview or briefing with Security Weekly and you're already planning to attend, please go to securityweekly.com/conference request. That's one word, to submit your request. I, for one, have really enjoyed InfoSec World. When I spoke there in the past, I think it was last year at this point, maybe a couple of years ago, maybe it was last year. And it's beautiful in Orlando at that time of year. So if you're not going, I feel sorry for you because it's a great time to go.
I'm also I'm presenting at the DevSecOps Symposium on Saturday before the actual conference begins.
Nice. There you go.
So they asked me to come down and speak on my security without friction talk. So I'll be there early.
Nice. That ought to be good as well. I was looking at some of the folks for that. Unfortunately, I had some conflicting, I think it was a travel schedule issue, so I wasn't able to be involved in the symposium other than talking to them a little bit about it. So good on you, Matt. That ought to be a lot of fun. There's a good number of people there. I think Kevin Johnson's going to be there. I'm trying to remember who else, but I was looking at the list the other day and thought this is a good lineup of folks.
Yeah, it'll be fun.
So with that, we're going to jump into our interview. But first, Mike Shima leads the product security team at Square. Mike's experience with InfoSec includes managing product security teams in complex environments, building commercial web application scanners, and consulting across a range of topics from network penetration testing to code reviews. He has put this experience into books and blog posts about information security with an infusion of references to music, sci-fi, and horror to keep the topics entertaining. His books include Anti-Hacker Toolkit, now in its 4th edition after decades in print, and Hacking Web Apps. He has taught hacking classes and presented research at conferences around the world. Mike, welcome to the show.
Hey, thanks, Keith. Great to be here. Looks like a nice full team out there, too.
Yeah. Needless to say, we got a whole crew today. So with that, I know that we wanted to start with talking a little bit about where the wins and challenges are in AppSec. Now, given your vast experience in the space, and especially the book, The Anti-Hacker Toolkit, I'm curious to know maybe the highs and lows just to start. What's maybe like the one thing that's either recently come out or maybe has, it's the age-old panacea that nobody seems to be using anymore that you like to talk about these days?
So I guess the age-old panacea is that prepared statements and SQL injection. Just please use them. They've been around forever, and that's just the best way to get rid of that class of vuln. So if you want an easy win, that's the way to go. But that's kind of old news. Honestly, that goes back all the way to 2003, 2004. A sort of more recent win that I like to really emphasize is talk about Let's Encrypt. because if you go back to even the early days of the internet, everybody, and especially the InfoSec community, was really talking early on about, hey, let's encrypt things. Please encrypt things, encrypt all the things. Please use HTTPS. And you saw a bunch of different presentations and sort of the theme of, hey, the sky is falling, nobody's ever going to fix this. And the reason I like to call out Let's Encrypt as a win is it really just said, rather than sort of that idea of complaining or just that doom and gloom that nothing is going to ever get better, they came and said, awesome, here's an engineering solution. We're going to make certs free for you. So it took away any budget concerns. And more importantly, they said, here is a protocol to be able to get a cert, provision a cert, and importantly, renew it. Because even to this day, everybody forgets about renewing certs. So if you want a good win that's an engineering effort, that's one I'd throw out there right to start off with.
Yeah, for me, it's funny with the InfoSec Mentors project. When we were setting that up, it's like, all right, we need a cert, and thankfully, Let's Encrypt was it's not necessarily new, but it was just kind of fresh, and a lot of the automation hadn't really been fully tested yet, and so we started it, and every few months we'd go in and we'd have to kick off the renew scripts and get it all running, and now I've got it just running on a cron job every, I think it's like 45 or 60 days or so, right after the timeline where you're allowed to renew your cert, and it's a breeze. It's like, okay, I no longer get those weird, hey, you have to renew your cert emails, and then, oh yeah, what's the password to that server, and what user was that installed under, and all that other goodness to get it running. So yeah, Let's Encrypt is a great way to do things these days, and I actually think some of the providers out there, if I'm not mistaken, like the Ghost blogging platform, I think is using either Let's Encrypt or they're maybe using another cert, but they offer certs like as part of your purchase. So it's kind of a nice thing that you're starting to see other organizations do is, hey, this whole Let's Encrypt thing is available, so we should probably start offering certs with all of our services because they're just so darn easy to get, which I think is kind of awesome.
Yeah, and I think one of the things you kind of alluded to there is just saying it's not like people don't necessarily, it's not like they don't want to encrypt things or they don't understand why encryption is good, but just being able to make a cron job and it just works, that's the awesome way to go. That's like security should, quote unquote, just work. And if I was going to talk about another win kind of along those lines, jump on, sort of what's old is new is old again is cross-site scripting. So cross-site scripting is going to be probably, unfortunately, around forever. And yeah, there's content security policy, which I think is awesome. So not to sound dismissive, even though my tone of voice might have conveyed that. But another like engineering approach is like apps using React.js as their front end, which just makes it really, really hard for developers even to introduce cross-site scripting in the first place. So if you're going from that perspective of, I want to build something new and I want an easy security win, and I don't want to worry about, old classic vulns like cross-site scripting, SQL injection, hit those prepared statements and absolutely go after something like React.js, because that way developers can just go and worry about something else rather than XSS.
Now, Mike, would your prepared statements be in React.js, or would there be some kind of like middle kind of language that would talk to the database?
So here is where, all the prepared statements, that SQL aspect of things is going to be on the back end, unlikely be in React.js. But React is that fantastic thing. It's a great metaphor because it's sort of that prepared statement implementation, if you will, for HTML. So you can build a web application and it's going to build the DOM for you, and you don't even have to worry about the context of where you're dropping in some user-generated data, some text. It can go into an intrinsic event, it can go into a DOM node, it can go into a header or search value, something like this. And you, for the most part, be safe, and unless you use that dangerously set inner HTML function. It's at least friendly named, so you can find it. So so it's a way to tackle your front end and the back end, get rid of that class of, good for those easy wins, those classes of injection vulns.
That's awesome. Yeah, I'm just trying to like design it in my head. So I've got React.js on the front end, I've got my prepared statements on the back end, I've got my content security policy in there as well, and SSL Let's Encrypt for my SSL cert on my app, and that's a good foundation for building a more secure app out of the box.
Yeah, that's absolutely going to get you started. That should be sort of that table stakes of getting started. And then we can start chatting a little bit about some of the wins that turn into challenges. And that's when you get into, hey, how do we actually authenticate users and do it well as what should we actually be worried about now, because
Right.
we can throw this onto AWS, and AWS is great, or any like the cloud-based type of development, but there's a lot of different traps now to worry about. So we could cross our fingers and pretend in this, chatting for about 10 minutes now, we designed our secure app from cross-site scripting and SQL injection. But admittedly, there's probably going to be a couple other mistakes that are going to crop up.
Mm.
So it's interesting that you mention prepared statements. One of the things that I often look to, Mike, is if the language or the backend, more specifically, has an object relational mapper. What are your thoughts on just kind of relying on those to do some more of your create, read, update, delete mechanisms to the database? Are all of them good? Are only some of them good based on your experience? Or is it more of you see people writing a lot of these things by hand, and so they just don't know about object relational mappers to begin with?
Yeah, so I think so. It's a big question with a bunch of different answers. I think my quick gut reaction is that it's all a good thing, and it's also I guess part of the reason I was sort of hesitating and figuring out how to answer that is SQL is not actually the only backend database that exists today. Of course, there's everything in NoSQL, as well as everyone just loves to drop things into like an S3 bucket or using Elasticsearch. So if we step out a little bit from just that normal, ANSI SQL type of backend, what you're describing, having that ORM type of backend, I think is a really good thing because it gives us a chance to start talking about linting and expectations of what an API should be doing. Meaning, is this really, at its core, a SQL injection attack is throwing in some syntax to change the semantics of a query. But if you can do something like a good backend, CRUD API, so that only the create creates items, or your verb is only doing what that verb was intended to do, that's probably a really good step. And conceptually, it should be a lot easier to review, to look through how well written things are and their assumptions.
And
For sure.
Exactly
Go ahead, Paul.
what could we have an example of an object relational mapper?
SQL, gosh, let me pull this up now. So I'm used to I'm working in Go right now. So GORM is the Go object relational mapping tool that you can use to talk to the database. I'm trying to remember the one I used for the InfoSec Mentors project. So I'm quickly pulling up my GitHub because it'll have it in there. But there are a number of them out there for any given language. So if you're writing on the back end, say Node is doing full stack JavaScript, for example, there are node-based object relational mapping tools depending on what database you're talking to. So there's for Mongo, it's Mongoose is the one that people use for a lot of the MongoDB stuff. And then there is, bear with me for just a moment, just gonna
So basically, like in my code, you wouldn't see like select star from whatever, right? I would get the database mapped to me in some kind of object that I work with, like any other programming object in my language.
Yeah, SQL Alchemy is the other one that I'm thinking of for Python.
Yeah,
that's the one that I usually go back to.
Yeah.
And there's probably more. I mean, I imagine there must be one probably for Java, .NET. Obviously, the Node Express kind of relationships that exist as well. But the ones that I know or have worked with off the top of my head are GORM and SQL, or the one I just said. Sorry, SQL Alchemy.
SQL Alchemy. Yeah. Okay.
Yeah.
Yeah.
So, Paul, it sounded like you had another question there.
No, that was my question.
Got it. Am I missing any that are popular, Mike? Because those are the ones that I always go back to, or the ones that I've used. But there's got to be tons of them out there.
No, I think you hit those, and I think one I had recent experience with is similar, like just active record in Ruby, and the idea really, philosophically, the thing I like about them, it's basically it's abstracting away the SQL, which double-edged sword. So you potentially lose some of the efficiency, and certain types of queries might become more difficult. But it makes you think about your data, and it also just ideally makes it a lot harder to get access to data that you weren't intended to. So that means like rather than the classic SQL vuln, injection vuln that's going to give you like dump the password hashes or get into like a command shell on a SQL DB, MS SQL, you're possibly just going to reveal more records of the same type. So it's still not necessarily a great thing. So you could still possibly do like a full table scan of everybody's home address rather than just like one person's home address. But it's at least, conceptually constraining how that data is being accessed and managed for developers. So that's sort of my like philosophical take on it. And why I'm giving it the thumbs up from this perspective.
And the other side of this as well is generally speaking, if you know you're going to have more complex SQL commands, you can make sure that they're being run from at least a user that has very limited provisions or authentication to the database. And then you can actually call it directly without having the user input, or making sure you're doing good user input sanitization before you run the command. So just because you're using an object relational mapper doesn't mean that you have to use it for everything, to your point, Mike. And a couple others, by the way, Paul, just to give our listeners something to go back to, is Loopback and Waterline are kind of two of the popular ones. Mongoose is another one. Sequelize is another. And then Type ORM are kind of some of the big three in the JavaScript space as well. So those are just ones to think about for our listeners. Loopback being kind of the bigger one these days. But yeah, to your point as well, Mike, optimization of the database, especially if the data set is very large, can get to be a real nightmare. And again, when you're looking at things like NoSQL databases, it can get even worse if you don't know necessarily what fields you really should be looking for or expecting. And that's, I think, one of the problems that a lot of applications have is they've been built with statements that were written right into the code and will take a user's input. And these applications might be years old. And so they were never built with an object relational mapping tool in mind. And so now introducing that can get difficult as compared to saying, okay, you have a SQL injection here that we detected. Maybe we should just go fix that statement or make sure we're sanitizing that input first. So maybe that's another good question for you, Mike, is to what extent are you really encouraging teams today to look at having allowable code versus disallowed code? People traditionally call it whitelisting or blacklisting. But I always see that as one of those situations where if you can effectively have an allowed set of code or set of input for different fields, it tends to stop a lot of the problems, even if you aren't using prepared statements. What is kind of your thoughts on that?
Yeah, that's a great segue, because I go back and forth on this because a lot of times I think input validation tends to be overemphasized, unduly so, and sometimes even just superficial, because what's really the more important is not so much what data is coming in, but where in fact are you using it? So, what's the context? So if we're talking about, today we're kind of talking about SQL injection and cross-site scripting, the context of an input going into, potential cross-site scripting vuln changes based on where it might end up in the DOM, or even is it dropping between double quotes, single quotes, an intrinsic event, something like that. So that's why I say like output encoding is much smarter there. And here we've been talking about SQL injection and whatnot. And I love the idea of let's just use prepared statements. And that way you don't even have to worry about what data is coming in. Now, there's a couple catches, because you also mentioned there's a bunch of legacy code out there, and even lots of areas where it might actually make sense, or people want to nudge a little bit closer to something that's more complex that is still a little bit of that scary string concatenation. So when it does come down to like field or type checking or input validation, I tend to be a little bit more on the side of, can you do something with a good type checking? So is this a number? Make it numeric. Or is there a certain length? So that probably a zip code is 5 digits, or maybe it's a zip +4, or it's at least something that is quote unquote sane. Same thing with strings, because there are some fun types of attacks even against password fields. So there's the old school, a little bit silly in this day and age, hopefully it doesn't exist anymore, of the or 1 = 1 SQL injection in a password field. But also too, let's say that an app is doing all the right things and they're using bcrypt with a nice high work function for their password, but they haven't bounded what the input password can be. And I dump in, something like a 1 MB password. suddenly I might get a really cool algorithmic denial of service attack against this poor app that's trying to do a 1 megabyte password into a bcrypt function.
Mm-hmm.
So so that's sort of where I see, like, go for type, go for reasonable lengths, but don't try to over engineer what the actual input validation should be or could be.
I love it. That's a really good way to think about it, is over engineering, right? Because sometimes we can be the creators of our own downfall if we are not thinking about this logistically, right? And to your point, having a fixed space that for people to work within, for example, I don't know, a last name doesn't need to be more than, say, 20 characters long. I mean, reasonably, maybe a little bit more. But then having the opportunity to put in effectively an unlimited amount, or even worse in things like XML external entities, where you can
Yeah.
denial of service things by repeatedly calling something that is, incredibly large. I don't know, in terms of newer vulnerabilities that are starting to be found out there, Mike, is there anything that you're seeing as maybe from a trend, or that you tend to think about a little bit more today than you used to, because in your teams, you're already solving the XSS and the SQL injection vulnerabilities. So what kind of falls next on that list that might be rising in terms of considerations, or even attack vectors?
Yeah, I think there's still under the umbrella of that idea of input validation is the lots of modern websites today live by user-generated content. And that content is often text, sure, but it's also pictures. People love pictures of cats, especially. I think we can just, queue up all of our jokes about how the cats are taking over the world or taking over our attention, what have you. I'll leave that as an exercise for the listener. But sort of one of the classic scenarios that still pops up are images and image parsers. So poor like ImageMagick and GoScript have had problems with this in the past. Either just a pure buffer overflow, dealing with parsing what are potentially a little bit complex preambles inside, whether it's a PNG or that other three-letter file format that I'll avoid pronouncing so that we leave the controversy out of this, or even JPEGs, things like that. And so these vulnerabilities have been anything from like another type of algorithmic attack, where there's a really tiny compressed image that decompresses into a factor of like 30,000 to 40,000 times bigger. So a 10K image becomes a couple megabyte image. That's a great way to blow things up. As well as, even if we get a little bit aside from that idea of input validation and talk about what's in the images, like metadata, that's just another thing to start thinking about, and making sure apps these days not only are considering about security, but also considering privacy, and what are the implications of not only how to handle all of this more complex data than text, but what does this actually mean inside it?
So many,
And actually,
I was just going to say, so many sites today allow you to authenticate with other services, into your privacy argument and security argument, right? I tend to, sometimes I find it convenient, and sometimes I find it like really creepy, and why would I ever use my Facebook login to log into something else? However, if it's Facebook related, like Instagram or something, that, okay, that makes sense to use my login. But if I want to use my Facebook login to log into some other app that has nothing to do with Facebook, why would I do that? Mike, what are your thoughts on how this kind of federated identity has worked its way into all these Google and Facebook and social media outlets?
Yeah, so if we wanted to talk about input validation for a long time, we could even talk longer about what password composition is supposed to look like, how many letters, how many digits, etc.
Yeah.
However, I like to fall into the NIST SP 863B, if I remember correctly off the top of my head, that basically said, let's stop worrying about password complexity, because all of that is really about after the password hash has been compromised. And let's talk about better multi-factor auth. Let's talk about those federated systems. And actually, rather than have the smaller new web apps who have small engineering teams with maybe not very, very much, if any, security knowledge, let's just push that authentication handling onto some bigger services, whether it's like log in with Facebook, log in with Twitter, LinkedIn, Google, of course, or any type of SAML-based service. I think overall, those are really good because it can move that point of identity off to somebody who has more resources to monitor it better, somebody who has by default thrown some options for multi-factor, whether it's anything as simple as SMS. Hopefully we're moving away from that, but onto push notifications or TOTP or even hardware like YubiKeys. And that way, people can start worrying less about their password or just worry about one password and then log into all these other systems. And I'll also throw in that really quick plug, just use password manager, please. That way you only have to remember one password. And if you don't want to go the federated route, let that password manager choose those 100, 200, 300 different passwords you need for all the sites you visit. And they're all different. They're all nice and unique, and you don't even need to know to remember them.
Mike, but using one of those services, do you potentially change the risk profile though? I mean, I get it from an engineering perspective, but look, we know the article we're going to cover in the next segment is all those Facebook passwords were stored unencrypted, right? I mean, that's a risk to your application because potentially those get compromised. Does that also impact your application from a risk perspective?
Yeah, so there's a couple interesting traps to watch out for here, and I'll jump around on kind of a couple different ones. One that's really interesting is let's say like Facebook password is compromised and my site's, a site is using login with Facebook. I may go in and reset that password, but a lot of these sites and the way they're set up, they're possibly using OAuth tokens or they're using some other type of service token that says, hey, this token represents Mike. And as long as somebody with this token comes around and presents it, let them in, and this person is Mike. Changing your password doesn't necessarily invalidate those tokens. So it's a different thing to think about. And if you are if you're building one of these web apps, as well as if you are that on the other side, being that identity provider, you need to think really hard and well about how you're going to manage that compromised account workflow and tell people, hey, we're either going to invalidate all of these tokens for you, which can be a really big hassle because now you got to go back and re-authenticate to reprove your identity in all these different apps, or you need to go and do it individually one by one. So even if I, go and change my leaked password, somebody with that token or, has compromised that token in some way might still have that back door, so to speak, or that additional access into my account. So that's one thing to think about. And you're right to call out, it's a different threat model. So there's another thing, you didn't quite mention this as well, but you are, 2 degrees centralizing where your point of access is. And we're building trust around, a Google or a Facebook to be able to handle that well. In this case, I think it's not so much I think we can say Facebook knows how to store passwords securely. I suspect what we would be talking about here is how does any website, including big websites like Facebook in this example, log post data and make sure that they're redacting that post data correctly, because passwords are notoriously, as well as other personal information, going to show up in that post data. And those are things you don't want to show up in logs, even though developers and engineers love to have logs so that they can just see, how are these apps doing? Something's going wrong. I need to go and debug something, and so on.
And it's funny because that's almost exactly what happened, how it was discovered for what we're going to talk about in the news segment. Matt or Paul, unless you have any additional questions, I have my 5 questions for Application Security Weekly, unless you guys wanted to jump in first.
Yeah, I wanted to briefly, Mike, talk about the challenges associated with securing applications today. And I think you and I discussed certainly the pace of change that has rapidly increased, especially in the past 5 years, and how we keep up with that.
Yeah, so one of the things is that, we're moving to a lot of cloud-based services. And I think that's awesome because it means that developers have more infrastructure and more systems that are actually abstracted into basically text files or YAML files or whatever the newest modern version of configs are. But it really means that developers can spin up systems fast, spin them down fast, push out code really quickly, and test their changes through a really efficient CI/CD pipeline. So they can go through A/B changes or A/B testing just to check with things. And I think that's all awesome. The double-edged part of that, though, is on the one hand, for as much as you're abstracting all of that systems and infrastructure into text files, it's cool that you can lint it, you can review configs, you can review changes a little bit more easily and from a more centralized spot. But in practice, it also means it's really easy to make really big, really heavily compounded mistakes.
Yep.
So, maybe picking on Facebook a little bit, or even Google has had outages in the past. One engineer, one human that makes a mistake or pushes through a small config change that doesn't have, hits a corner case that wasn't tested for, can have this massive cascading fallout that can often be really hard to recover from. Because once you have a bunch of interconnected systems that are all, included from this config file and this config file, but depends on this, suddenly you have this really interesting graph of services that might introduce, a bunch of cyclic dependencies, a bunch of weird dependencies, stuff like that. So it's awesome, but it's also a little bit, you definitely have to be a lot more careful because the mistakes you can make are much, much bigger.
Yeah, it's interesting. Was it last week we went to the Ocean event? Was that last week?
Yeah.
So last Tuesday night, I was, of course, the night before I was supposed to give my presentation, updating my slides, and Google Drive and related services were down. And in almost the same time frame, I realized Facebook was down as well. And my conspiracy theorist was like, this has to be related. I think from everything that I've heard and seen, it was just a coincidence. And I think probably more so, I think Mike gave a great description of why a widespread outage like that might happen to the major providers.
And I think that actually happened last year, didn't it? Or no, excuse me, 2 years ago. US East for Amazon was down early 2017 for almost exactly the reason that you just cited, Mike, which was just a flag that was misentered either in the configuration file or manually. It took down all of US East 1. So
yeah, totally. I think we'll get to the point where our conspiracy theories our threat model has to start including, chud or, the mole people that are underground chewing on fiber optic cables, just like the squirrels are going after our, electrical grid, but we're not there yet.
But so we talked a lot about some of the quick wins when it comes to kind of the big OWASP top 10 kind of things, but this is different now when we think about pushing code changes, pushing configuration changes. What does that do from an application security, like future vision of what else are we going to have to do besides just SQL injection protection, cross-site scripting? There's got to be more now because we're enabling through the DevOps process the ability to change things quickly. How do you catch those before they go out? And what additional tooling or processes are we going to need to implement that we haven't done yet?
So I think the future is great from an AppSec perspective. And I think, that whole idea of DevOps and the CI/CD pipeline, it does a couple things. One, it just gives more touch points on a very predictable deployment path to be able to hopefully go in with a tool. And maybe it's an old school, static analysis, maybe it's dynamic analysis, maybe it's just a simple grep and linter. All those can be great things that can watch this pipeline and just trigger off new builds. The other thing it does is pushing a lot of the responsibility for security onto DevOps teams themselves. So hopefully more humans are aware of what these issues are. But what you were kind of leading towards is like, we're going beyond just those simple injection style attacks, and it's that data. And what we don't really have right now are really good ways of watching how apps are handling data, as well as if we're going to start leaning a little bit into that Venn diagram of security and privacy, what's data is being collected, how is it being stored, and even how long is it being stored for? So do we have CI/CD pipelines or test cases that are actually considering how data is going to be deleted and how quickly it can be deleted? Or can it be aggregated really quickly so that we can de-anonymize, or so that we can make something more anonymous? So I think it's going to be, we haven't solved it, but we're doing a little bit better on injection, a lot better, I'll say, on injection, a little bit better on just application development. And that's just going to push us on to dealing with the actual data that a lot of these apps are collecting and handling.
Yeah. New areas for new solutions, I guess.
Mm-hmm.
Indeed. So with that, before we let you go, Mike, we have 5 additional questions for Application Security Weekly. Are you ready?
Oh man, I wasn't prepared for this. Let's go for it.
Perfect. So the first question is, what were the specs like on your first computer?
Commodore 64. The thing was awesome. I learned how to peek and poke with that.
Nice. And while you were using your Commodore 64, what programming language did you learn first? And if you're writing anything today, what do you enjoy writing in?
So that was definitely BASIC and copying basic programs out of magazines so I could play the most fun, Godzilla game or what have you. Today, I've gone a little bit beyond, line numbers, and basically for me, Python is pretty awesome, quick and efficient for scripting up quick things. And I will throw in a shout out to R because I've had, a side desire to dive into visualization and play with data, and R has been pretty fantastic for that.
Nice. So we are going to pull you into the holy wars a little bit and not have you pronounce either GIF or GIF, depending on who you talk to. But we will ask, Vim or Emacs?
Oh, that's not a holy war because the obvious answer is the sign of the beast, of course. VI, VI, VI.
Nice. And then, of course, then the next question being, while you're writing Python code, spaces or tabs?
That's why you have VI just handle it all for you. It's all spaces. And I will shout out, Perl was one of my earlier languages. Nobody can read anybody else's Perl. Python is nice because you can ostensibly read someone else's Python code because of those space or tab-like characters that show up in there. Spaces.
Well said. So the last question we have is, what sort of advice would you give to newcomers in the industry?
Participate a lot with engineering, meaning like write some code so you actually know how apps are built rather than diving in purely just like bug bounties. I think bug bounties are a great place to learn because you have a lot of real apps that you can pick apart. But actually writing code, if you want to dive into Go was a great mention, Python, plenty of front-end JavaScript type of languages. Just start building something so you can understand all the mistakes that get made, as well as have a little bit of appreciation for how to be clever. And rather than come up with use cases in QA, you're going to be coming up with abuse cases in your pen testing. So write some code, then start to pick things apart.
I love it. Awesome. Well, Mike, thank you very much for joining us this week on Application Security Weekly.
Thanks. Had a great time.
Thanks, Mike.
Cool. Stand by, folks. We will come back with the news in just a moment.